Hey everyone, Daniel from AngelDAO here. In this video, we're going to walk through how to store the Ethereum data that we collected in the last video in MongoDB. So to recap quickly, where we left off was getting our events from the Ethereum blockchain. These events are the borrow event, which is an event that's emitted from the ETH-DAI contract, the vault contract from Fuji. And we pass those events through our for loop to format the data to create this event point. This event point is going to be the points that make up our time series chart, and the chart will show the amount borrowed cumulatively over time. So to start, again, this is the video changelog, which represents all the changes from the last video to this one. All these will be present in the GitHub repo along with any notable changes since the last video has been shot. First, we have scraper.js, and this change is pretty simple. We are just exporting or adding main to the exports so we can import it to server.js. So pretty simple change here. Next, we have the DB directory, which is where we are connecting in the code to MongoDB locally via Mongoose. So we're using Mongoose to connect. And here we have the event point schema. Next we have the models directory, and inside there we have the eventpoint.js file, which basically defines our model or schema in this case. So if you can see inside the schema here, this is made to match up with our points that we are creating in the scraper.js file, so they can be added to our DB. And next we have the services directory, and just to speak to that quickly, services is just my way of, I guess, separating the logic, making it more modular and potentially reusable. So the first service is going to be the add mini service, and we have the isUnique function and add mini function that is receiving the events as an array, going through it with a for loop, running the isUnique function, and if it is unique, then we create the event, otherwise we do nothing. Next we have the index.js, which is just a code pattern to import all of the services, so we can export the services, all of them, as an object and instantiate each service by chaining off the EPS service naming convention, which just makes the code more readable. The next service we have is the last block service, and we are fetching the DB to find the last event added sorted by block number, and we return that block number and create the last block const here, and we pass that const into the scraper function. The block number that get passed in will be used in this ternary here for the from last param. And so you can see here, passing in the const, it's coming in as a parameter, and it's being used to either resolve to from last or the start block for the contract. And this basically just saves us time, so we're not having to query by the longest block distance every time. Next we have the server.js file, and this creates our endpoint for Grafana to hit, so eventually we will be using that with Grafana. First thing we do here is obviously get the last block from the last block service. We then pass that to the scraper. The scraper returns the events that exist in that block time frame, and we add the events that are unique, and then we finally query the DB to get all of the events and set the return equal to the const events, and then respond to the request with the events. Now that we've walked through the code, let's get our DB and server running and see if our code works. First thing we need to run is MongoDB, and I had to add that flag for my installation. Next, we're going to run the Mongo console or make sure we have the right DB. We don't, so we need to set the right DB, and there we go. Next, we're going to run the server. Okay, our server successfully started. And now we are going to send a GET request to our server endpoint at localhost 4000. The scraper started and the logs are starting. We got 86 events from the Ethereum blockchain, so our connection to the blockchain is working. Okay, our scraper has ended. And we have successfully added 86 events to the DB. So let's just verify. We are going to run some queries against our event points collection. So we're just going to run the count method. Cool, so it says 86 here. So let's see what our server responded with. Values, block numbers. Looks like 86 to me. So that's going to be it for this video. In the next one, we will be passing this data along to Grafana and displaying it as a time series chart. See you in the next video.